Okay, hi. Thanks for coming. So I'd like to show you some kind of shiny demos of some different visualization tools. I think visualization is a field that's really moving and advancing recently. So I'd like to sort of give you a bit of a history of that in the Python context, and then show you some projects that nowadays are sort of out there and available to do some quite interesting things. Now, I suppose since about 2002, we've had Matplotlib, and it's been developed over a long period of time. It's stable, mature. It's got great documentation. 2,600 pages of documentation last I checked. It supports lots of different file formats for export. It supports several different platforms and different windowing toolkits on different platforms. Okay, but it's not really for interactive plots. Now, I'd like to show you the kinds of interactivity you can achieve with Matplotlib and what that might be useful for, first of all. So I'll flick over to this. Now, so here's a very simple example. This was written a long time ago by Eli Bendersky. It's just a basic Qt kind of or Qt interface with the ability to move this slider to increase the width of the bars, and you can sort of add numbers and so on, and the plot updates. Okay, that's a very minimal level of interactivity, but it can be useful for some applications. Of course, this is designed for a desktop, so it can't be shared on the web. But this is the Matplotlib interface. Can I have a show of hands, please? Who's used Matplotlib before? Okay, so you'll be familiar with this and how you can pan around, you can zoom, and you can save in different file formats and so on. Okay, so that's a very simple example of interactivity. It's just refreshing this canvas, which is embedded inside the application. Now, there are some other things that can be done. I'd like to show you this one in particular. This was written by Jake van der Plaat as a sort of demo of what's possible a couple of years ago. So this is kind of frivolous. You just move around this Rubik's Cube, and you can play with it and things like that. So this is all done using Matplotlib. There's some quite interesting maths behind this, involving quaternions to actually display this cube. It's not trivial. It's not simple code. But it's possible. It's quite interesting. It's the most interesting sort of 3D kind of visualization I've seen in Matplotlib in some ways. So that's Matplotlib. Now, it's been around for a long time. And it does the job. It's great for publication quality plots, so that's what it was originally designed for. I know I wrote my thesis plots with it, and a lot of other people did, and it's kind of useful in various contexts. Okay? So now there was a set of tools written by Enford. I think about probably 10 years ago, started development with sort of Chaco. I'd like to show you some demos of Chaco. Maybe a show of hands, who's seen Chaco before? It's a somewhat older package. It doesn't support Python 3. It may never. We'll see. It does the job though. Here's a nice little example of the kind of interactivity that may be useful for some cases. See the way these sort of the colors and the sort of contours move as you move the mouse around this sort of contour map. It's quite interesting. So there are a whole lot of really interesting demos here. So if you haven't seen Chaco, it may be worth just browsing the demos to get a sense of the sorts of options you've got available. So this is an older package. It seems to have languished a bit in development recently. This is the sort of the one I found most interesting initially. This is something of a kind of a meme, I suppose, at sort of SciPy conferences giving sort of spectrogram demos. this is, yeah, so anyway, it's sampling from the mic at 11 kilohertz and doing Fourier analysis and displaying that. So, yeah, so the resolution is not terrific, but it's okay. It's not bad, and it's doing that together with the visualization as well. So I guess there are various kinds of applications of interactivity. Here's another example. This might be data coming in from some sensor or some, I don't know, whatever, so any real-time data. It can just sort of be plotted and sort of updated and so on. Okay. But first of all, I guess I'd like to swap back to this and show you Makai Map of the world. So David Makai is a physics professor at Cambridge University. And he's written a book called Sustainable Energy Without the Hot Air. It's a really good book. And he's got this map, this sort of chart where he shows, it's, let me see if I can zoom in, make it a bit bigger. Yeah, so we've got different countries with their land area and their, I should move over the axes. We've got energy consumption per person on the vertical axis, and we've got population density there. And the idea is that different countries have different profiles, and this sort of makes it possible to have different kinds of production of energy from renewable sources. Okay, so this is a log scale, and these lines indicate if the entire surface area of the countries were covered in, for example, solar panels, how much energy could be produced per person given the number of people who are in that country. So it's a really interesting way of visualizing the opportunities different countries have for renewable resource usage. And so, for example, Australia's over here. It's easier for us than for just about any other country to make use of renewables because we've got lots of land and not many people, and lots of sunlight. So that's interesting. Now, one thing about this is that it's a static plot. So it was made for his book. But he's got all sorts of different versions. Look. So in this case, he's got one here with sort of, yeah, it's sort of slight variant there, showing something different, and this. Okay, so, and all these other versions as well. So, and this is just crying out for interactivity. Okay, so lots and lots of static plots, and sort of, this is the kind of thing that can be done really well with an interactive interface. So I'd like to show you now this. D3 Gapminder. Hans Rosling is a demographer who gave a talk, a TED talk a few years ago, which was very popular and well received. And he looked at something a little bit different to this. He looked at how population tapers off as as countries come out of poverty, and had this chart of all these countries sort of moving up here. This is a similar one with some other variables here. So we've got income per capita on the horizontal axis, and we've got life expectancy on the vertical axis over time. So you can see as a history, see this huge one's China, this is India, this is the USA, and I guess UK and Germany and France. I think the little brown one there is us, I think. So yeah, over time, you can see how that moves, and that's quite interesting as a way of visualizing our data set and getting a sense of how it's evolved over time. So this is a demo put together by Mike Bostock, the author of D3, and this is using the D3 JavaScript visualization engine. It uses the DOM, manipulation of the DOM, so with SVG elements. Okay, that's the way D3 works. Now, there are other opportunities for this too. So there's I suppose in more recent, in the last couple of years, there's been this package Bokeh, which Continuum Analytics has been sponsoring and pushing forward, and they've done a great job in doing this. And the idea is that there are all of these visualization libraries in JavaScript now, which can do quite amazing things. And yet. That's in JavaScript. So how do we get access to them from Python? So, so the idea, one of the goals of Bokeh is to make it possible to create visualizations that are interactive without the need to write JavaScript. So that's a nice goal. At the moment, for some kinds of interactivity, it really does still require a little bit of sort of JavaScript tinkering. But I think as time goes by, more and more widgets are going to be pre-built, which allow you to do more and more in terms of visualization of data without using JavaScript. So I'll give you some demos of this, and one in particular is very recent. It's a very similar one to what I just showed you. This is it's just only in the last couple of weeks been available as a Bokeh sort of source repository example. So this is using Bokeh instead of D3. Now I'm trying to make this bigger. All right, let's try that again. Okay, seem to have some browser challenges. There we go. Okay, so there's a degree of interactivity here. So we've got a slider. It's updating the data on this canvas. This is using HTML5 Canvas. So the new canvas element. So it's a different technology to SVG. In theory, we can do more with it. It can be faster because SVG is about objects and manipulating objects. This is a sort of a raster, a canvas that we can draw on. Okay, so anyway, that's it's pretty good that even that's possible. Yeah, and this wasn't possible until quite recently. So this is a Python charting package which actually has a Matplotlib interface, as well as interfaces to, well, I suppose Seaborn. It's also based on Matplotlib, but yeah. Yeah, the Continuum has been doing a good job with this this package in particular. It's there are lots of examples which are worth seeing. I'll just maybe go to the down up here to give you a sense of the. Here we go. So the kinds of things you can do with it out of the box. So here's an example of two plots, and they just move around. So if any of you have used D3, you'll know it's quite a low-level library. So it doesn't even sort of give you zooming functionality, for example, into plots. It's something that really requires sort of doing that yourself, and it's fairly straightforward if you're comfortable with that. But it does require a bit of code. So anyway, this is possible without any JavaScript and just Python code, just plotting this data. And there are several different layers to the interface. Sort of low-level layer, and at the top level there's a charts layer, which is designed to be, I suppose, and have an interface based on the grammar of graphics, which is the sort of philosophy that's behind an R plotting library called ggplot2, which has been very popular. Now, yeah, so it's quite a nice way to construct plots. So with all of these, this is R, now RStudio. So I don't do very much in R, but I do have a bit of R envy when it comes to visualization. There are various packages like this one, 3JS. You can just install it in one line and sort of flick it up, and here, I guess this is a different one. So yeah, sort of visualization of a data table. Now, the one I wanted to show you, oh yeah, okay, we've got various kinds of options for different sorts of 3D plotting as well. So I'll flick over to, I've got that as a, so anyway, so this is this has come up in a sort of webby kind of canvas, and just with a couple of lines, it's using this, I know that's very small text, but it's using this sort of scatterplot3.js library, which is available for R, which just wraps a corresponding JavaScript library. So it's possible to do this, and And yet, in Python, there isn't a lot yet that allows us to do this. So there could be so many more packages which just wrap all sorts of weird and wonderful JavaScript visualization libraries. That the scope is there. So if there's a project you've been looking to sink your teeth in, an open source kind of contribution you've been looking to make, I'd say this is a kind of an area that's really ripe for that. That it's not too difficult to just wrap JavaScript libraries and provide an interface from Python, and it's quite interesting. So so in particular, I suppose it's RStudio's a company, and they've got Leaflet.js, and they're sort of sponsoring various bits of development with this, for example. So this is a nice one involving mapping. Okay, so we've got our map using OpenStreetMap. We can just zoom in and out here and pan around and so on. Okay, and that's just made using this R code. Now R is no better than Python as a programming language. It's a lot kind of, I don't know. It's not really used outside statistics, but the R developers have made that available, and we can do the same kind of thing for Python too now. But at the moment, it's in its infancy. But there's a lot of opportunity there because there are lots of JavaScript libraries these days. All right. So a couple of other things I'd like to show you. In the last few months, it's probably been about a year in the making, but it's really in the last few months it's got going that there's that's become visible. A package called VisPy, which is a collaboration between what were three or perhaps four developers who are working on separate visualization libraries. And this is quite interesting. This one actually uses OpenGL, so I'd like to show you some demos here. So let's see if that works. Okay, there we go. All right, so we've got, this is using this VisPy library. It's one of their canned examples. It's a brain structure. I don't know if the coloring makes sense or if it's, or what, but it's potentially interesting as a way of visualizing the structure in some 3D data. So in this case, there's no interactivity aside from that, but yeah, we can zoom in and out. We've got various other interesting ones as well. Some of these have a sort of science focus. Here's apparently it's a knee molecule. Anyway, you can sort of zoom in there, and you see, because it's using the graphics card, you've got sort of, I guess they're quite fast, but they're all individually sort of shaded. They've got their own light sources and so on. So it's quite interesting. And I suppose OpenGL has been traditionally used primarily for gaming and for some kinds of high-end computer-aided graphics and engineering. Last one I'll show you here. This is really interesting. This is, I think it's 100. I don't remember. So anyway, each of these little signals is, you can zoom in there. It's got each of these is like its own real-time data source. It's just random noise in this case, but it just shows this sort of the speed you can have visualization of. So yeah, this package was designed originally for neuroscience and neuroimaging, and the charting packages that were available weren't good enough at the time. So yeah, how am I doing? All right. Yeah. Now a couple of other things I'd like to show you now are about how this can potentially interact with the Ipython Notebook. So. So what we've got here, yeah. All right. So the Ipython Notebook has these nice, rich display elements and widgets for interactivity recently. So that allows us to do some interesting things. But also, yeah, so I'll come back to that. Also, that VisPy it's possible to use VisPy to write to WebGL elements. So the three main technologies for visualization in browsers are SVG, HTML5 Canvas, and WebGL. And WebGL is really an extension of the canvas. And I think one of the goals of the VisPy project is to bring more of these kinds of plots to the browser. This is the only one that seems to be working at the moment. So OpenGL code it tends to look like this, very C-like, involving writing vertices and shaders and so on. But now here's an example of, is this going? No, okay, I'll restart the kernel. Okay, so there's that example running within the Ipython notebook, and this is zoomable as well. Okay, so it's pretty responsive. It's pretty good. So there's been some amazing work going on here. So there was a great talk about VisPy introducing it at the SciPy conference in Austin, Texas, just recently. So this VisPy project has really come from nowhere in the last few months, from what I can see too, and it's got quite ambitious goals, and it's sort of going places. And website is also new, so this, yeah, it's interesting, and there's this nice gallery too. This is all pretty recent. So yeah, and these are the kinds of demos that are there in the source repository. All right. So yeah, the page. I was looking for the name of the person who gave that. It was terrific. VisPy SciPy 2015. It's worth watching. Yeah, Luke Campagnolo is one of the developers. He's been doing an amazing job with this. Yeah. So now I'll close that. I suppose the next thing I'd like to show you is, oops, I don't want to load email, is around what else can be done with the Ipython notebook, because there's the opportunity to kind of make use of these widgets and so on that are offered now to do interesting things. And I'd like to show you one particular around Pandas Dataframes. I'll make a new one. Should be, no, sorry, one sec. Okay. Right, that's the one. All right. So, that's the one I'm looking for. You have a show of hands who's used Pandas, and who's seen so Pandas in an Ipython notebook with the HTML output for the data frame. Yeah. So that's an example of the rich display that Ipython has, but it can get a lot richer. So here's an example of wrapping a JavaScript package called SlickGrid, which displays tables of data. And in a sort of interactive way, you can sort the columns and things like that. And there's a nice little Python module called QGrid, which is made by a company called Quantopian, which is in version 0.1.1 or something at the moment. So, but it seems to do the job. So what I was able to do was to use this package and just to patch pandas. So this you'll be familiar with. This is the usual Pandas data frame output. It looks like that. With this little patch to Pandas to use this QGrid module, it comes out like that instead. Now notice that was really fast. So this is all all daily Apple stock prices from 2000, I think, to 2012 or so. So it's quite a lot of data, maybe about, I don't know, yeah, I guess whatever, 4,000 data points or something. Let's have a look. Okay, 3,200, yeah. So anyway, it came up pretty instantly. This one also takes a while. Not quite sure why, but anyway. So we can sort. We can just change the sort order. We can sort on these other criteria, like the prices. We can have filters as well. Look at this, date range filter. So let's say, okay, let's go from 2005 instead. Didn't enable that. Okay. It can filter the prices. Let's say all prices in that range. And look, the number of rows is decreasing. So if the filter is small enough, it's yeah. Then sort of, there we go. That's it. That's the total number of rows left after selection. So this. Let me show you the patch needed to make this. So that's it. Okay. So it's overriding this Ipython display method on the Pandas Dataframe. Thanks. And so yeah, to just call this the corresponding method returned by this showGrid function from QGrid. Okay. So this is the kind of thing that can be done with Pandas. This is just only actually doing this if it's installed. Otherwise, it just falls back gracefully to the regular output. So now it's also possible to use pivot tables, Excel-style pivot tables for interactivity. Yeah. So, but I'm out of time, so I can't show you that. But there are quite a lot of opportunities, and it's a really interesting, dynamic field, and it's sort of moving fast. So now's a great time to get involved with this visualization as a topic if you're interested in that. Okay, thanks. Thanks.
Thank you very much, Ed. It breaks my heart to try and stop you at that point because you're showing so many excellent things. Really, thank you.
Thank you.
Anyone wanting to come up here and ask questions? Yeah, come on up.
By the way, any hard questions, I'm going to defer them onto Ryan Kelly.
Hi there. Thanks for the presentation.
Okay, you're welcome.
Thanks for the presentation. Forgive me if I missed, but what about mapping real-time data into the 3D platforms like Maya or 3D Max and such, softwares to create models, what they call mesh?
Okay. Yeah, I don't have a lot to say about that. Are you familiar with the MyRV package in Python? So it's quite an old package for visualization with. But yeah, I don't have a lot to say about that. Sorry. Can anyone else answer that question? Okay.
Anyone else want to come up for a question? No? I think we're all overwhelmed by all those graphics. They're amazing.
Shiny day. Well, none of them are my work. I'm just sharing other people's work.
You're the medium through which we saw them.
Okay.
Thank you for that.
Okay.
Yes. All right. Well, yes. So let's thank.
Okay. Thank you. Thanks.